The last thing we're saying is that if you take a vector, like the vector u, and you do u cross u, so the cross product with itself, then the result is the 0 vector. The cross product u cross v, where u and v are any two distinct three-dimensional vectors, that cross product is going to be a vector that's orthogonal to the vectors u and v. We have this formula where theta is the angle between the vectors u and v. And again, like I said last time, that should look really suspiciously familiar to the a similar formula we had for the dot product, right? Where we said cosine of theta was equal to u dot v divided by norm u norm v. And then the last thing I said is that the norm of the cross product is actually the area of a parallelogram with u and v as the sides of the parallelogram. So if, let's just work this example. It says, find a unit vector that is orthogonal to both a and b. So I know that a cross b is a vector orthogonal to both a and b. And so that would be a good place to start. So a cross b is going to be this. Hopefully you guys remember from last time. This is going to be the determinant of this matrix, where I'm going to put the entries of A in the second row and the entries of B in the third row. And so the way we calculate this determinant is we say that this is I times the determinant of this 2 by 2 matrix minus j times the determinant of this matrix plus k times the determinant of that matrix. Okay? What is this first determinant of this first 2 by 2 matrix? -2, because it's -3 times 0 minus 2 times 1, and then I have minus j times what's this determinant? -2. Yeah, because it's 1 times 0 minus 2 times 1, and then what is this last determinant over here? 8. Because it's 1 times 2 minus 2 times -3, so that is 8. So my vector A cross B is then going to be my vector -2, +2, 8. And so I know that this vector is orthogonal to both my A and B vector, but my question says find a unit vector that is orthogonal to both A and B. So a unit vector, remember a unit vector is just a vector whose norm is 1. And if I find the norm of this vector A cross B, that's not going to be 1. That's going to be a pretty large number. So we just need to normalize this to get my answer. So my unit vector, let's call it V, is going to be whatever this vector is divided by its own norm currently. And so if I want to take the norm of this vector, this is going to be the square root of -2 squared plus +2 squared plus 8 squared. Yeah, square root of 72, which is like 6 root 2, yeah. So, for my answer, to get my unit vector in the direction of this a cross b vector, I just have to take each entry and divide by 6 root 2. So this would be like negative 2 over 6 root 2, 2 over 6 root 2, and 8 over 6 root 2. And there's probably a nice way to simplify and like make this look nicer, like negative root 2 over 6, positive root 2 over 6, and then two root 2 over 3. Is that right?
With the simplification, would it give us any points less if we don't simplify too much?
No.
Okay.
No.
So because like in the homework, whenever I was looking at like checking my answers,
Yeah.
I got confused. I was like, how did I get this wrong? And then I look at it, it's like it's just simplification.
Yeah, that's okay. This is what is called rationalizing the denominator, and so it's important. It's important, like if you were out taking a multiple choice test, because unlike a multiple choice exam, a lot of times your answer choices might be given in this form, and after you've rationalized the denominator. But if it's an open-ended question and you gave me this as an answer, that would be fine. That would be full points. Okay, so we'll move on to the next example. It says the vertices of quadrilateral ABCD have the following coordinates. So I've got a quadrilateral, which means I have 4 vertices A, B, C, D, and I can link them all up with edges, and it's a 2-dimensional shape that looks like that, right? Quadrilateral means that it's 2-dimensional. If I just had any 4 points in 3D space, that's what I meant to say. If I have any 4 points in 3-dimensional space, that doesn't necessarily make a quadrilateral, right? You could have 4 points in 3D space that are not in the same plane, and so you wouldn't be able to connect them up to make a nice flat 2-dimensional quadrilateral. But in this case, the problem is actually telling us that we do have a nice flat quadrilateral with those 4 vertices. But there's still a bunch of other questions we could ask geometry-wise, like in the space of quadrilaterals, some quadrilaterals are also trapezoids, and some are not. All right, so what it means to be a trapezoid is that one pair of opposite sides are parallel to each other. All right, so sometimes the quadrilateral has that property, sometimes they don't. Among trapezoids, some trapezoids are parallelograms. Not all trapezoids are, but some of them are. And so, out of this set of trapezoids, some of them are parallelograms. And what it means to be a parallelogram is that actually both pairs of opposite sides are parallel to each other. And some parallelograms are rhombuses or rhombi. I don't know what the right pluralization is. But some parallelograms are rhombus, and others are not. What it means to be a rhombus is you are a parallelogram, but all of your side lengths are equal. Okay? And some rhombuses are squares, but not every rhombus has to be a square. And actually, it'd be better to draw it like this. It'd be better to say that among parallelograms, there's also a set of rectangles, right? A rectangle is a parallelogram, but it's a parallelogram where the corners are all 90-degree angles. And then if you are both a rhombus and a rectangle, that makes you a square. So you probably remember this. This is just a review of like second grade geometry. But whenever I ask all of these questions about this quadrilateral, we're just trying to narrow down about like what properties does this quadrilateral have? Because we can actually figure out if it has each of these properties, right? So asking if it's a trapezoid means I have to find the vectors that describe each of these sides, like the vector that stretches from A to B, and the vector that stretches from A to D, and the vector that stretches from B to C, and then from D to C. And I can ask myself, is the vector that stretches from A to B parallel to the vector that stretches from D to C? Okay. And if you haven't seen this, if I haven't used this notation before, this notation is a vector where to find the entries in that vector, you just subtract the point B from the point A. So this would be the vector where I would have 2 minus 5 as the first entry, and then 6 minus 2 as the second entry, and then 1 minus 0 as the third entry. So this AB vector would be -3, 4, 1. It's the vector that has its tail at the point A and the tip of the vector at the point B.
So they should be equal or scalar multiples?
If I'm asking, is the vector AB parallel to the vector DC?
Like for the purpose of this example.
Yeah, so it depends on which question we're asking. But if I start with asking, is it a trapezoid, what I'm doing is I have to look and see, is this vector AB parallel to DC? And if yes, those are parallel to each other, then this is at least a trapezoid, because I have one pair of parallel sides. If not, if these are not parallel, then I could check the vector BC and the vector AD. Say, are those parallel to each other? And if they're parallel, then I have a trapezoid and I can move on. If both of those pairs of opposite sides are parallel, then I would have a parallelogram. And again, I wrote this equation up here, but this is how you check if vectors are parallel. If one vector is a scalar multiple of another vector, then those vectors are parallel. Okay, so how would I check if it's a rhombus? Remember, a rhombus has all sides equal length. So I could take the norm of these 4 vectors and see if they all have the same norm. In that case, I have a rhombus. I could check if I have a rectangle. How?
The opposite side equal length?
Yeah, opposite sides could be equal length. That also might...
Parallelogram at the same time.
Yeah. You could have a parallelogram with opposite sides equal length, but you need all... Oh, you said all. Yeah, you said... Okay, if it's a parallelogram and all sides are equal length. Oh, that would just be a rhombus.
Opposite sides equal length.
So what's special about a rectangle is that the corners are 90 degrees. So that means these adjacent vectors would have to be orthogonal to each other. You would need the vector AB to be orthogonal to the vector AD for this to be a rectangle. And the way we check if vectors are orthogonal is we take the dot product and see if it's 0. Because if vectors are orthogonal, then their dot product is 0. And the last thing is if it's a square, then it's both a rhombus and a rectangle, and you can do that. And then how would you take the area? Well, I'll tell you, this question is set up so that this is a parallelogram. Because we can take the area of a parallelogram by taking the norm of the cross product. That gives you the area of a parallelogram.